Uh, Welcome to the HPRC primer, Introduction to Faster, a Composable cluster. My name is Abhinand, and in this session, we will give a quick introduction on our latest supercomputer Faster and the hardware and the new features that it provides. And then we will quickly see how to access these resources and what all softwares are available through this and how to submit a job in this. Let's get started. All right. Faster is our latest supercomputer here in Texas A&M High Performance Research Computing Center. It stands for Fostering Accelerated Sciences, Transformation, Education, and Research. This is a 180 node cluster from Dell, and it has has all the NVIDIA GPUs, as you can see here, A100, A10s, A30, A40, and T4 GPUs. And the 180 compute nodes, these compute nodes are based on Intel's Ice Lake processor. So coming to the nodes, we have a login nodes which you will be using to submit these jobs for the supercomputer, and there are compute nodes where the actual computation happens, and there are also two large memory nodes which will have 1 TB memory, and the other compute and login nodes usually have 256 GB of memory. There are two login nodes, two for TAMU users, and one is for access users. We will show how to get into this login nodes in the subsequent slides. And apart from this, each of these nodes have a 3.84 terabyte disk space, and the 5%, the 5 petabyte shared Lustre file system. And this is a new feature in Faster, which is composable accelerators. Right now, these are the accelerators that these are the accelerators that are available for Faster. Around 200, exactly 200 T4 GPUs, which has 16 GB of memory, and around 40 A100s, A10s, and A30 and A40s. And these are made available to the so these are composed using Liquid's PCIe Gen 4. So this is the hardware that enables the composability. And speaking about composability, this is a new feature of Faster. So if you see the other supercomputers like Grace, right? If you see on the left, this is a traditional server configuration where you can see there's a server and there are fixed number of accelerators that are kind of hardwired into it. So if you request for a node, so that node can only use those 2 GPUs within the node. So you cannot add any more accelerators on it dynamically. So let's say here you can see there is one node. The green color represents the GPUs, and red color is the memory. You can see there are some nodes with 2 GPUs. There are some nodes with 4 GPUs. So that's the case with Grace. Actually, Grace has A100s, a fixed number of A100s in a compute node, and that's the only node you can get. Whereas with this new architecture, we have this composable set of resources. Like we have a server pool, and we have a bunch of accelerators, a pool of accelerators sitting there, and we use this extended memory in SSD storages as a memory composable resource. Now, using this Liquid Fabric, we will be able to dynamically, compose a server to the configuration of our requirement. As you can see, you can like dynamically request for 3 GPUs a node with 3 GPUs, and there's a node with 6 GPUs. So you get the flexibility to compose this the node as per your requirement. Now, this was not possible with the traditional server configuration that we have in the previous systems. So this kind of enables you to do all kinds of new computations that you can do within a single node. That's the one of the major advantage of this. And right now, the GPU composability, like so how you can add the GPUs is using the job file. So to submit the jobs onto this supercomputer, you'll be using Slurm scripts. By adding a JRS option, we will go over this briefly in the subsequent slides again. And there's a session on Slurm. After this, if you can, if you register for that, you can know all about it. But you can specify the JRS option, where you can tell the number of GPUs that you would like to have for that job, and it will dynamically compose the server for you. And right now, you can request up to 12 GPUs to create the CPU and GPU nodes. So as I said earlier too, so this kind of approach kind of allows more flexibility and provides more options for the users. So these are the kind of main features of this, the main hardware features of faster. Just a quick pop quiz. Can you guys just type in what accelerators are available on faster? Yep. We got all of these accelerators available actually, T4, A100, A10, and A40s. And as I said, you can compose them dynamically as per your requirement. Now we'll move to how to access these resources. And so these are like we use this through batch computing. So users connect to like there are multiple ways to connect to the login nodes. We'll again show this in the next slide. Once you go to the login node, you'll create the Slurm job script, where you specify what is resources that you would like to have for this compute job, and you submit this job script to the Slurm. So the job is queued in the Slurm batch manager, and whenever the resources are available, it will just deploy the job, and you will get the output files. So this is the batch computing process. Now we'll see how to get onto the login nodes. As you can see, for students on campus, you can just directly connect to the TAMU Wi-Fi network, and you can just SSH into this login nodes. For people who are outside the campus, this is for the TAMU users, you will have to connect to the VPN, and only then you will be able to SSH into this login node. And for the access users, there's another way to do that. We'll show in the next slide. So for SSHing into the faster, like we can use either MobaXCOM for the Windows users or PuTTY SSH. People also use Windows subsystem for Linux, but it is kind of known to throw some issues when people are using VPN. So yeah, MobaXCOM and PuTTY are kind of one reliable ways to connect. And for people using Mac OS systems, you can just open a terminal and you can just SSH into the systems. I think SSH is installed in these systems usually. This is the command that you need to type in once you open your terminal. You type SSH, give your net ID @ faster.hprc.tamu.edu. For the scope of this primer, we won't be supporting the SSH login for the access users, but we will show how you can access it through portal, like a web portal. Yeah, and once you type the SSH command, you will be asked to provide a two-factor authentication. This is for the TAM users again, not for the access users. So this is similar to, this is again similar to the Howdy login. So where you just have to provide the geo approval for you to log in. I'll just quickly show you how it is done. Right. I'm a Windows user. I just opened the terminal. Can you open the PowerShell? Can you see my terminal? I hope. Let me know if you cannot see the terminal. Here you just give your NetID password, and you will be prompted with the. So you need to give the geo option that you would like to have. So once you approve, you will be able to log into the terminal. So there's one more way to access the portal, access the login node, that is through the portal. So if you just go to the hprc.tamu.edu website, here I have it here on the left side, you have this portal option. So again, this is only for the access users, and this is for the TAMU users. Just click on it. So it will just prompt you for your NetID password. This is very similar to the Howdy login that you usually do. And once you enter the user ID password, it will again prompt you for geo two-factor authentication. And you can just log in and use the resources. And for access users, this will be slightly different. I'll just quickly switch this over to Aditi. So she can show you how it is done for the access for people from for the access users to log in. Now coming to the portal, so this is people who are kind of familiar with terminals and Linux systems who can operate through. Maybe they can go with the terminal route, but this is this is more user friendly. And if you're just like a very new, like a beginner who is not familiar with this kind of systems, you can use portal to navigate through the system. So here you can see the file systems and everything, and like you can upload and delete files here, edit the files, and there are like you can launch interactive apps. So you can also launch interactive apps like Jupyter notebooks and other things. There are sessions later which shows you how to use these Jupyter notebooks on HPRC systems. Please sign up for that if you are interested in knowing about these things. You can also see like what are the interactive sessions that are currently going on. So there is another shell access you can get through this. It's again the same terminal that I got through the Windows PowerShell earlier. So you can like if at all, like you don't have any of this installed, or you don't want to open it, we can just operate from this browser window only. Again, it's the procedure is same. You give your NetID password, and you specify your you give your geo authentication, and once you approve it, once you approve it, you will be able to access these things again. Yeah, this is just how to access faster via HPRC portal access. Let's go to a quick hands-on activity. Please try to access faster now through portal, and just let me know like what is the message that you see on the shell once you log in. And if anyone's facing issue, you can just if you're facing issues with mobile XM for today, maybe you can just try using the portal. The URL for the portal is pasted in the meeting chat. The password is your NetID password, the same one that if you're a TAMU user, it's the same one that you use for your Howdy login, right? in case I'm just showing this again for people. Once you log into the portal, this is what you will be seeing. And here, if you come here, you can see the shell access again. You can use this shell again to like get the shell access to the login nodes. You just give your password to authentication. Yep, and you will be able to see this. And just a quick note on the login nodes. These login nodes are for you to submit the jobs, and please restrict the usage of this login nodes to 8 cores only. Like if you just you should, 2 reasons you should be using this way. These are shared resources. Multiple users will try to like log into this, and they'll probably test out some things that you like you shouldn't. It's unfair for other users that you take up all the resources. And other thing is, even if you just try to perform some benchmarks and all, or some performance, you will not get good performance on this anyways. And you should always submit a job to the compute node through Slurm, and that's what you should be using. And if at all you use more than, like, you'll probably get a mail from us suggesting you not to use that. Okay, I hope everyone is able to log into this and log in and get this shell access. Now let's move on to understanding the file systems and user directories. So now this is another important thing that you need to be aware of. So there are 2 directories that are provided to you. One is a home directory. Another is a scratch. Home has a space limit of 10 GB only, and the number of files are limited to 10,000. Now this now we limit this because these are kind of nightly backed up, and most of your jobs most likely will require much more space and file limit than this. For that, you need to use scratch directory. Now the scratch has much more space limit. You get up to 1 TB. The file limit is like 250K. And you can always see how much more space is left for you using the command show quota. Like, I'll just like show it out to you here. I have a much larger quota because I requested for it, but it would be specific to your account. So if you apply for initially you will be given only 1 TB of space limit and only like 250K of file limit. If at all you need more allocations, like more file, more space, you can like send an email to help@hprc.tamo.edu. Like for smaller allocations, they kind of get approved faster, but if it is ranging from more than 10 TB or that, probably you will probably need to provide some justification. But you can of course send us an email and get that approved. And also these extra allocations are usually done for like these are temporary allocations. These are for 6 months only, so they need to be probably renewed for your purpose. And one more thing is, this scratch directory is not for you to use as a storage option. There's no so these are only for your compute resources, and these are not to be used for as a storage option for you guys. And yeah, and you can always get the limits increased if it is not suiting to your requirements. And also, please don't share your home and scratch directory. Let's say you want to you change your read write permissions and etc., and you will always run into some trouble, and it's not the best way for you to share your scratch directory. Please request a group directory for sharing files. Again, you just have to send us an email through help@hprc.tamo.edu, and we'll allocate a shared directory. Here you can see I have a group directory here called scratch group HPRC, which we will be like using to share the contents. So you should probably go that route instead of like giving permissions in your Scratch directory to some other users. Now, coming to the software, we have a list of software installed for you already. You can see it in this page in hprc.tamu.edu/software/faster. These are all the software modules that are installed for you already. And if at all you don't find anything like that you will be needing, you can always like contact HPRC for a software installation request. And also you guys like also the users can install the software in the Scratch directory. And please do not run sudo command when you're installing the software in the Scratch directory, as like it will kind of notify us that someone's trying to access. You won't have the sudo command for it. But if there is a possibility for you to install a software without having the sudo permissions or without having to like change some restricted files, you will be able to install them in your Scratch directory. And also we provide some licensed softwares like MATLAB. And again, these are kind of like they are given to the users on first come first serve basis. When someone is using, there'll be like a set of licenses, and when someone has already taken them and currently using, you won't be able to use them. It's kind of a first come first serve procedure. Now, moving on to loading these softwares. So these installed applications, right, they are made available with a module system. So Faster uses a software hierarchy inside this module system. And if you have used Grace, this is similar to Grace. Grace is another supercomputer in HPRC. So in this, so the user loads a compiler toolchain, and it will load the software which is built with that compiler toolchain only. We will see, we'll go over a couple of commands to see how to see what are the available software and how to load them, how to like purge them from like the session. So just the first command is module list. It just shows you the current modules that are loaded in your shell environment. So currently I haven't loaded anything. So as you can see, that there's nothing there. Now I can just, so GCC is a compiler like for some I think people, if you know, there are multiple versions of it, and there are different kind of GCC compilers. So I would like to load GCC core version, as the module list is going to currently show you the currently loaded modules. All right, now sometimes you would have to load a different set of dependencies for a particular version of module to work. Let's take this case. Now this, so if you see now, yeah, we will try to load this OpenMPI. So this will require us to load a dependent module before that. Now, if you can see that in the message that it will show you, if you type this, see, so it is requesting that there are a set of dependent modules which needs to be loaded before you load the OpenMPI 4.1.1. So it also suggests you how to figure out which modules to be loaded before this. So we'll go over those comments now. So it's just like, let's say you in general, this is the process that I go through. Let's say you would like to load a particular software module, and you just type module spider OpenMPI /4.1.1. Now it is suggesting you to load one of these compilers before you load this. So you just go ahead and load that module first. It also says it. So earlier we loaded this module, right? Now it's been swapped with this module. Okay, now you can go ahead and load the OpenMPI module. Let's go see. These are all the modules. So you might think I just loaded, you might think like I just asked it to load the OpenMPI 4.1.1, what are all these modules, but these are all the dependencies. So you need to have these loaded for you to load this, and the module system automatically does that for you. But you need to you need to load a dependent, like if some dependencies can't be resolved directly, you can find it in the module spider command. So this is the, like, let's say just to go through another example, let's say you are interested in loading a particular Python module. So you just go and type module spider Python. Now it's going to show you all the Python versions that are available through this, right? So you can just identify the particular Python version that you'd like to have for, like, and then just again type the module command. And please don't forget to, like, before you run this commands, please don't forget to do the module purge. Now this will clear up all the loaded modules, and you can just Python. And if, let's say, I want to load Python 3.9.6, I might just type module load. It's suggesting me to yeah. So yeah, it suggests you to load this GCC core 11.2.0 before you load this Python 3.9.6. This is one of the common use cases probably you'll be using to run some AI jobs or deep learning jobs. You'll probably using some Python scripts for this. So you just go ahead and load the GCC core module, and you can just go ahead and load the module Python. When you type Python, you can have the particular version of Python running immediately. Yeah. So there are variety of compiler libraries and tool chains that are available on our clusters. Again, you can find these using module spider commands to see what all GCC core versions or what all Intel versions are currently available. We just listed out some of the available compiler tool chains, and module spider probably is your best friend, like when you're trying to navigate or like resolve what necessary modules that you'd like to have. And as I said, we just, again, I'm just showing it again for you guys. If you're just trying to see what all Intel compiler toolchain are available, just type module spider Intel, and it's just going to list it out for you. All you need to have is this name correct, and you will be able to find all the available versions of the toolchain. And please remove, a good practice is to do a module purge first and ensure that there are no, unwanted modules already loaded, and then start loading the modules that you'd like to have. Let's just move on to a quick hands-on activity. Please search for the GCC module, GCC 12.1.0, and try to load that. And if at all you're running into some issues, please put it in the chat. We can help you. I hope everyone is able to do that. I'll just quickly show how it is done. As I just again, just do module load GCC. Oh, let's see if there are other modules already loaded. We'll just purge this first. using module purge command. And then we just load the module that we want. It was able to load it smoothly. If at all there was some dependence that were needed, it would have thrown that error message that we have seen earlier. And you can see all the modules that are loaded for this. Again, just purge this and keep your environment clean. But I think so one user asked how to see the current configurations. What are the states that are available? Actually, this is one quite useful command that I rely on to see what are the GPUs that are available. pstat gives you all the nodes, how many of them are available currently. As you can see the partition of it, the state of it, like what are the users that are currently using, and you can see how many are free. And you can apply some filters to, let's say you want to see only the GPU partition. You just type pstat -p GPU. So you can see all the GPUs that are all the GPU nodes that are available. Okay, let's move on to understanding how these computing resources are kind of built, and how you can see how much we can use further. So as I said earlier, when you submit a compute job, the resources are specified in a Slurm job file. In that you specify the number of processor cores that you need, how long the job will take to complete, and also you specify the number of GPUs that you want. Once you give the specifications, based on the amount of compute that the job is going to be needed, you'll be charged service units. Now, service units are like your bank balance in the HPRC system. For each job that you submit, you'll be charged a number of service units. And how these service units are computed, you can find how this service unit is computed in our wiki page. It gives a detailed account on how they are computed. It will be different for a CPU only node. It will be different for a a node with GPUs and all. I highly recommend you to look at it if you would like to understand how your charged SUs. Now, if you want to know how many SUs are left in your account, so when you apply for a basic account, you will be given 5,000 SUs. Sometimes let's say you are working with some professor, he can request for a research account or a startup account, and he can allocate you SUs from that account. As you can see here, you see there is a default, there's one account that is called default. This is basically the basic account that you would be requesting for with 5,000 SUs. And in this instance, the user have used like 71 SUs already. This is the PI, like under whom you are working. Like so when you request for an account, you usually put in the PI name, and we send an email to them for approval. Like if they don't, once they are not really approved, we just inform them for 3 days. After that window, we'll go ahead and provide you the account. And on the other, and you can see the other entry, which has like some possible 1,000 SUs. When you submit a job in your Slurm script, you specify the account number that you would like to charge with. We'll show you a Slurm script in the subsequent slide, and using that account, the SUs will be charged to that account. And other like and for the software licenses, you'll be using the license status command. It kind of shows all the software, licensed software that is available, and how many licenses are available for you to use. So you can just type license. Now, these are all the licenses that are available. You can see how many are issued, how many are used, are like currently being used, like when someone is using. So this is, again, as I said earlier, these licenses are given out first come first serve. When a job is running, they'll be like using a certain number of licenses. If there are any left out, like, if there's still some available, you'll be able to proceed with your compute job also, else you will have to wait. Like in some period of the semester, people, like, you might run into issue, like you might face a situation where all the licenses are currently being used, and you'll probably have to wait for a certain amount of time before you are able to use the software. And if you just want to see the license status of a software that like, you are interested in, and just type like something like MATLAB. So yeah, this will give you the current issued MATLAB licenses, how many are available. And if you would like to know more options, you can just use license status help command. This will give you more options on what all options are available for this command. If you would like to check, like once you're submitted job, like before submitting job, you might, sometimes your job might be denied, and the first thing you should probably see is your project balance. You just type my project. It gives you the number of SUs that you have. For me, it's different. It will be different for different users. Like if at all you would like to change your default account to a particular number, a particular account, you just type my project -d and the account number. And you can see the default account has changed here. There are many more options, like for my project, for a detailed option, you can just use the H flag to see the kind of options that my project will provide you. Just a quick hands-on activity. Please try to see the SU balance for your accounts, and also check like the license status of MATLAB we just saw earlier, and just try to see if you're able to execute those commands, and just like probably put in the chat like how many licenses are available right now. I hope everyone is able to do that. If at all you're facing some, what is the command to check the license? Yep, the command was license status -s and the software that you are using. So as you can see the license name is MATLAB, and 50 are issued and none are being used right now. And there are 50 available for you to be 50 are available right now. And again, just my project will give you the account balance. Now, now let's discuss about job submissions. So job submissions are kind of auto-assigned to batch queues based on the resources request. Like depends on the number of course nodes that you requested, and also on the wall time. These are kind of auto-assigned. These are queued into the Slurm, and based on the availability, Slurm will kind of schedule your job. It will all this is kind of managed. This workload is managed by Slurm. And if you want to see what are all the queues that are available for Slurm, you can use the command sinfo. Now this gives all the partitions that are available. There's a CPU partition, and you can see whether it is up or not, and what is the time limit for this queue. Like currently it's around, I think it's 7 days, and the job size is It's, I think I think as far as I know, it tells you the number of CPUs in the core. Uh, uh, but yeah, and it also shows how many nodes are available. A stands for active nodes, I is for idle, O is for offline, and T is the total number of nodes. Yeah, that's a GPU partition, and you can see how many are available right now quickly. The other nodes might not be available. These are kind of restricted, but yeah, you can see the availability in the each queue using this. And if at all you would like to run a job which potentially runs for a longer duration, let's say it's running for more than 7 days or something, you should probably say, you should send an email to help@hprc.tamu.edu, so that we ensure that the job doesn't get killed after that time limit. Also, one quick thing: when you submit the job, uh, ensure that you're giving enough wall time, because the Slurm will kill the job after the computations, or after it runs for a certain number of duration that you have specified in the job. Let's say if your job is, you specified it as 1 hour and your job runs for more than 1 hour, the Slurm is going to kill your job, unless you have a way to save the state and resume the job. It's highly recommended that you give a bit extra buffer, and whatever you actually used is the only thing that you will be billed for. So if at all you give the extra time, you won't be billed for that. It'll only compute for the actual time that was used. So yeah, please be mindful when you are submitting a job that way. Now, just I'll just show you a sample job. So this is a Slurm job script. So this hash, you provide this hash dispatch in front of every option that you are going to Slurm. So each of these options tell you the amount of time that you would like to run, like hyphen time. Oh, sorry. Yeah. 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 This is the job script. So hash dispatch is a Slurm directive. When Slurm reads this text file, right? Whichever line has the hash dispatch, Slurm knows to read it as a command, and it will parse it, and it will read the option that you are providing after hash dispatch and space. So hyphen n task is kind of the number of CPUs that you would like to have, and hyphen mem is the amount of memory that you would like to have in the job. And also you can specify the account that I told us earlier too. You specify the job account, your project account that you would like to be charged for this job. And you can also give an email address for which so you will be sent a notification when the job completes for that email address. And once you give all the Slurm directories in the first two sections, then you start your shell, your bash script for the software to run. So first you clear off all the unwanted modules, then you load the exact modules that you would like to. In this case, it is Python 3.7.0 Intel 2018B. You load all the required modules first, and then you give the you give the command to trigger your software or trigger your compute job. Now, once you finish this script, you use the command sbatch to submit the job. All right. So this is what you will be seeing once you submit the job. You just type the command sbatch, and this will be your Slurm script. Once you submit the job, it will show you the SUs that are being charged for this, and how much balance is left for you, what account is it charged for. And once you submit the job, you use the command sq -u and your username to see the status of your job. So it will give you the it will give you a job ID and the partition that it is running on. Like has so the state tells you whether the job has started running or not. Here in the second job, you can see it is running, and how much wall time is left for this compute job. And if at all it is pending, it gives you the reason. Actually, like it's pending because the resources are not available. And once it picks it, it will give you the node that is currently using too. Yeah. So we'll move to the next part. Just a quick hands-on activity. Like please do try to submit a job, create a job submission file, and submit the job. This job file using the dispatch command, and check how it is going on. You can see the also you can see, and just see if you are getting the output properly or not. We are running out of time, I think, but please do try doing this. And if anyone is if anyone is facing any trouble in creating a Slurm script or anything, you can refer to this slide to create the initial options to submit a Slurm batch script. We'll come back to this. Before we close, I just want to let you know about these things. If you are facing any issues with or if you like to know any information about HPRC wiki is the first place that you would go to. Most of the common problems are listed out there, and there is a user guide for you to see how to run these jobs. And if you if at all you face some issues, you can send us a email, and we would respond. We will try to resolve the issues for you. And when you submit the email, please try to include the cluster that you're using, your username. If at all you have the job IDs that have failed, and whatever application that you're using, so these kind of steps makes it easy for us to understand the issue faster, and we'll be able to provide a faster guidance to you. And also there are other primers that are going to happen after this, which talks more about Slurm and its options, how to use Jupyter, how to manage your data on our clusters. Please sign up for those if you'd like to understand how to efficiently use those things on this cluster. Yeah, thank you very much. And if anyone needs help in submitting a sample job script, you can send a message. You can put the message in meeting chat, and I'll try to help you with that. And also, we also have a YouTube channel. Please subscribe to that. We do have a lot of sessions that we lot more trainings that we conduct throughout the semester, and you can see all the recordings for those in this YouTube channel. Thank you very much.